Hi everyone. In this video we're going to be working with the 2012 AP Free Response question. And we're going to be working with question number 2. So if you happen to have your calculator, take it out because we're going to be using it to evaluate points on our graph. Now in this question it says, let R be the region in the first quadrant bounded by the x-axis in the graphs of y equals ln x and y equals 5 minus x as shown in the figure above. What this question means is we're going to be finding the area as well as a volume at some point whenever you see a question like this. So because of that, what I'm going to do is when you have an equation like this, make sure that you put whichever one this is, whichever equation this is, and whichever equation this is. Since this is a line, I can pretty much say that this is going to be y equals 5 minus x, therefore this has to be y equals ln x. Now your next thing is, okay, well let's go ahead and find the area. Well, what you're taught in calculus is to find the area, you have to find everything that's in between a curve. My first curve, and x equals 0 because it's bounded by the x-axis. But you'll notice this equation corresponds from 1 to up to this point, and then it changes equation and goes to 5 minus x from this point to 5. Because of that, we have to find out where this point intersects. And the only way we could do that is using our graphing calculator. So then you're going to go to your graphing calculator, go to the function button, y equals 2, and then type in both equations. Doesn't matter the order, I'm just going to type in ln x and the other one 5 minus x. I'm going to graph it, and what you should get is a zoomed out version of what you have on your actual AP exam. Now this is the portion that we're looking at, so what I'm going to do is I'm going to zoom in. Zoom button, number 2, zoom in. This little plus sign, you see right there, scoot it up to where it intersects, press enter, and you should get what you're seeing on your actual paper. Now our next step is, well, let's figure out where it intersects. We know it intersects somewhere there, but let's actually calculate it. Second thing, CALC for calc. Intersect, because we're trying to find out where two lines intersect. First curve, I usually just put it on the left, enter. Second curve, I'll usually put it on the right. And my goal is to calculate when they intersect at this point right here. Then for guess, press enter, and the intersection is at 3.693, y equals to 1.3065. What I normally do is I normally keep 3 or 4 decimals. So I'm going to keep, for this purpose, 4 just to be safe. And that's the point where they intersect. So at this point right here, it's 3.6934. So now because I'm trying to find the area, well, I want to find the area from here all the way to here bounded by 1 to 3.69. So that's an integral. So for part A, it's going to be 1 to 3.6934 of ln x, and then minus 0 because that's what it's bounded by, so I'm not really going to write that. Dx, you have to make sure you put dx because you will lose a point if you don't put that. Plus 3.6934 all the way to 5 of the next equation, which is 5 minus x dx. This is the integral for this portion, and this is the integral for this portion. Now my next step is to just plug into your calculator. So then I'm going to go back to my home page, and then when you click on math and you scroll all the way down or press number 9, you should get the integral button. Press 9 and it should set up an integral for you. And you're going to type in exactly what you have on the paper. So 1 all the way to 3.6934 ln x respect to x plus the other integral. So math number 9, 3.6934 all the way to 5 of 5 minus x respect to x. Press enter, and it should calculate your area. So this area, region R, is equal to 2.985, or we can round it to 6, or you can keep it as 0.985, and that's the area from finding the area from this, on this curve and on this curve, and you add it together to get 2.986. Now for this question, you'll actually notice there was an easier method. The easier method was not breaking it up into two different actual areas, but rotating it. so that this curve is always higher than this curve. And that's what we're going to do now. When you have this equation, if I were to rotate this, what actually ends up happening is this entire equation is higher than this entire equation from every single point from 0 all the way to 1 point something, which we already know those values. We already know those values because we know that at this point right here was 3.6934, comma 1.3065. So from 0 to 1.365, that's where the area is being calculated. So we're going to set this up. But the problem is, if I set up an integral from 0 to 1.3065, these are my y values because this is my y-axis. So this equation right here and right here have to be in terms of y. So what you have to do is you have to take it to the side and go, okay, well, y equals to ln x. I need to solve for x to make it in terms of y. So you get rid of this ln by applying an e. So you get e to the y equals to, e to the y equals to x. And then the same thing for y equals 5 minus x. And you're going to end up solving for x so that you get 5 minus y is equal to x. So this equation right here corresponds to that one. Ln x corresponds to e to the y. So now you have to ask yourself, okay, do you have a curve higher than the other curve at every single value? You actually do, because if I draw a line, this curve is higher than that one, higher, this one's still higher, and throughout the entire region. So because of that, this equation has to come first, which in respect to y, which is 5 minus y. And then I'm going to subtract it from the bottom curve, which would be ln x, but because it has to be with respect to y, minus e to the y, dy, and that's your equation. So sometimes you have to look to see which one is it easier. Is it easier to do it in respect to the x, or is it easier to do it in respect to y? To do it in respect to the y, I would always rotate my paper here to figure out, do I have an equation higher than the other equation at every single value? Then when you plug that into your calculator, clear your screen, go to the math, the integral button, and then just type in what you have. 0, 1.3065. Now, I wouldn't use x's, I wouldn't use y's, I would just use x's. It doesn't really matter. Press enter, and if you calculate it, you'll get the same exact thing. So both methods work. The question is, which one do you feel more comfortable with? And on your actual AP exam, you're going to be asked to find it in respect to the y and respect to the x. So it's one of those you just want to practice. So the second that you get your actual AP exam, keep it like this in respect to the x. Notice that you have to separate into two different integrals, but also rotate it to see if you have a curve higher than the other curve in respect to y. Alright, so moving on to question part B. This equation is saying region R is the base of a solid. For the solid, each cross-section perpendicular to the x-axis, this is huge. When you read cross-section and they tell you the shape, this is very, very important. You have to know, to find the area of the square, it's always base times height, but more importantly, the base and the height are equal to each other, so it's pretty much like saying x squared. Remember that. It tells you, write but do not evaluate an expression involving one or more integrals that gives you the volume of the solid. Now, we're not rotating around this. So because we're not rotating, we don't need the word pi. All we need to do is be able to figure out, okay, how do we find the volume when the cross-section is a square? When you read that, there's only one method. So in this cross-section, because it's perpendicular to the x-axis, everything has to be in terms of x. So we're going to take what we use as our area for part A, which was the integral from 0 to 3.6934 of ln x dx plus the integral from 3.6934 of 5 minus x dx. That right there is your area equation, which we already know. But they're telling you that this shape that's occurring is a square, and that the base is the area that we found in A. So this right here is your base. Well, if you notice, a base of the square gets multiplied by the height, and it's the same thing as saying x squared. So that's saying that this area is being multiplied by itself. So I'm going to end up squaring it, because this is your equation. Your base is your area times your height, which is the same exact thing, would give you ln x times ln x, ln x squared, 5 minus x times 5 minus x, 5 minus x squared. You have to remember that a cross section all depends on this shape right here. Because it's a square, these repeat as squared. And that's your equation for part B. Moving on to part C. Part C is a tricky question. Anytime they ask you to find where a line would make them equal to each other, it's pretty tough. So then your next step is, okay, well, the horizontal line y equals k. So a line y equals k at some point, this is just a random line I'm drawing, divides this region into two equal areas. Write but do not solve an equation involving one or more integrals whose solution gives a value of k. Well, if you look at this, it means it wants me to find this k value that's right here, but this is with respect to the y. So because of that, you have to actually solve it in respect to the y, which we already did in the beginning in doing it in part A. So that means, okay, I'm going to cut this in half so I could figure out both areas. Well, that means I'm going to go from 0 to k, and then you're going to put, okay, well, what was the equation of the area? What we said in respect to y was 5 minus y minus ey dy. That's your equation. But you don't actually have to solve that because you know what this area is. You know that this area is 2.986. Well, what's our goal? Our goal is to figure out what k would divide us in half. So multiply this area by half, and that is going to give you your answer. And then you multiply that by 0.5, and then whatever you get, that's your answer. And you can leave it just like this or actually calculate it. So whenever they ask you to break off your area into two different regions, you have to make it in respect to whatever equation you have. In this case, it was y equals 2, so it had to be in respect to y. Write the area equals to half times the area because you're taking it and cutting it in half, and that's your final answer. Okay? So thanks for watching. Hope it helped, and good luck.